In question 4.4.5, we're going to consider the data given in the accompanying table. We're going to complete parts A through D. So this is our table. We have two rows, y1, which is row, which is 10, 40, 30, y2, row 30, 60, 50, and we have three columns, x1, x2, and x3. The first thing we want to do is we want to be able to construct a frequency marginal distribution. Now, a marginal distribution of a variable is a frequency or relative frequency distribution of either the row or column variable in the contingency table. Now, to create a marginal distribution for a variable, we're going to calculate the row and column totals for each category of the variable. The row totals for each category are found by adding up the cell entries in the column of that row. So, for example, for the first row, y1, we're going to add up 10, 40, and 30, which gives us a total of 80. And the row totals represent the distribution of the row variable. Now, if we want to go ahead and add row 2, so if we take 30 plus 60 plus 50, and that's going to give us 140. Okay, now what we want to do is then we want to be able to take the columns. So the column totals for each category are found by adding up the cell entries in each row of that column. And the column totals represent the distribution of the column variable. So if we look at column x1, if we add up 10 plus 30, that's going to give us a total of 40. If we add up 40 plus 60, that's going to give us 100. And if we add total here, 30 plus 50, which is going to give us 80. Now, the other thing that we should pay attention to is that if we add this column together here, we're going to get the value of 220. And likewise, if we add up this row, then we're going to get a total of 220. And therefore, this finalizes our construction of a frequency marginal distribution. Now, part B, they want us to construct a relative frequency marginal distribution. Now, the relative frequency marginal distribution for the row variable is found by dividing the row total for each row variable by the table total. So if you noticed that our row table total was 220. And so in this scenario, if we add 10 plus 30, that gives us 40. And therefore, 40 divided by 220 is approximately 0.182. And then we would do the same thing with the next column. If we take 40 plus 60 and divide that by 220, that's going to give us 0.455. And if we take 30 plus 50 and divide that by 220, then that's going to give us 0.364. And likewise, if we go with our rows, if we take 10 plus 40 plus 30 again, if we take 80 and then divide that by the table total, which is 220, that gives us approximately 0.364. And then we're going to do the same thing. If we take 30 plus 60 plus 50 and divide that by 220, then that gives us a total of 0.636. So the relative frequency marginal distribution for the column variable, again, is found by dividing the column total for each column variable by the table total. For part C, we want to be able to construct a conditional distribution by x. So in order to do that, okay, the conditional distribution lists the relative frequency of each category of a variable given a specific value of the other variable in the contingency table. So what we would do is we would take the value of 10, which is the element of the first row and first column, and divide by the total column, which is 40. Therefore, that's going to give us a result of 0.250. And then if we take the element in the first row, column 2, which is 40, and then we divide it by the total of that column, 40 plus 60, which is 100, then we would get the result for 0.400. And similarly, if we take the row 1, column 3, 30, and divide it by the total of that column, 30 plus 50, which is 80, then we get 0.375. And then likewise, in row 2, we're going to take 30 and divide it by the column total, which is 40, which gives us 0.75. Again, we're going to take the element in row 2, column 2, which is 60, divide that by the total column, which is 100, which gives us 0.600. And likewise, for the final one, we take 50 and divide it by the column total, which is 80, to give us 0.625. Now, if we want to draw a bar graph of the conditional distribution found in part C, then this would be our bar graph. And what we would notice here is that we would have our two bar graphs. So the first one's going to represent, x1 is going to represent the 0.25, and this represents 0.75. So you can see here the first column and the first row is 0.25. That represents the blue bar graph. And then 0.75 represents column x1, row y2, which is 0.75. And then likewise, the next blue graph is going to be 0.40, and this becomes 0.60. And then the last part is 0.375 and 0.625.